So the first job that we were at showed a real estate sale, and it was a result of an inspection for the existing septic system that was failed. So a new installation was being done, and that included an advanced treatment unit as well as a smaller size drain field it was a smaller drain field that the ATU was allowing. We used some different equipment. We have specifically on that job site, we had a mini excavator. We also had a laser level to make sure that all of our elevations were correct from the house out to the drain field. For that job specifically, we had to start from the house and work our way out. So the first part of this was to find the proper elevation of the line coming out of the house, the main sewer line, and then connect the advanced treatment unit so that then we could get our proper elevation for the grade for the drain field out in the front yard. We have to make sure that the ATU is set properly. There's certain installation instructions for that from the manufacturer, so we have to adhere to that. What we're doing here is we're digging out the actual drain field. We're setting all of our corners, making sure that the right square footage is being dug out. There was a lot of clay in the front yard, so we had to get rid of the clay. Luckily, there was a neighbor right down the street who wanted all the clay. Then we have to put in our select fill. The engineer specifies that, as well as it's specified in the code. And then we build the stone and pipe system on top of that, cover everything over. Of course, get our inspections in the meantime, but cover everything over, finish grade it, seed it, straw it. That way grass will grow and solidify stabilize the soil. Yeah, today was basically, again, the result of a real estate inspection, a septic system inspection for real estate transfer. What we found during that inspection was that the system was unsatisfactory. It wasn't draining water. That system was an existing chamber type system. It was not draining properly. A biomat had formed at the bottom of it, which was preventing the water from draining through into the select fill that was originally installed. So here what we're doing is we're digging out the material, we're getting down to the chambers to determine how much water is actually in the drain field. We're using a John Deere excavator. We also have to have a pump truck on site to be able to get rid of all the standing water that was in the chambers as well as in the tank, so we have kind of a dry bed, a dry base, in order to reconstruct the system from the bottom up. It was definitely over 5,000 gallons. It's probably going to approach 6,000 gallons by the time everything is said and done. What we're doing here is we're removing all of the old chambers. We're starting to remove all of those so that we can get down to that level of infiltration. What we're doing here is we're digging out the back end of the bed to make sure that we've gotten rid of all of the water out of the drain field. Once we pull the chambers out, we determine where the biomat layer is, we determine how thick the biomaterial is, and then we get an engineer to come out and physically test the soil. We test the soil directly underneath the biomaterial layer, which is also the level of infiltration, or the LOI. We also have that engineer test the soil 2 feet underneath that, and then all the way down to the original excavation based on the original approved design. Based on those test results, then we'll be able to reconstruct the system. We'll either have to go down to the original excavation and replace everything from the bottom up, or if that soil is okay, just start at that LOI layer plus 1 foot and replace that all the way up to the surface.